Okay, so in this problem we're told that the length of the rectangle is 3 more than its width. So I would actually start this off by quickly sketching out a rectangle, right, where our length is 3 more than our width. So here's our rectangle, and our width will be this, let's say, and this will be our length, but instead of length we'll say w plus 3, right, because the length is 3 more than the width. So this again is our length, but we're defining it in terms of width. So whatever the width is, the length is 3 more than that. We're also told the area is 40, and our goal is to find the length. Okay, so this is going to be an interesting problem because first we have to find out what's the value of w, right? Because w times w plus 3. In other words, the width times the length is the area, and the area is 40. So here I distribute the w, so w times w is w squared, plus w times 3 is 3w, that equals 40. Now to solve a question like this, a quadratic, a great technique is to subtract the number here over back to the left-hand side. So now what we do is we have w squared plus 3w, right, and minus 40, and that equals what? Well, 40 minus 40 is 0. So now we have this situation. And here this might not seem like we've gotten anywhere, but now we can factor this out. And the fact that it's equal to 0 will allow us to quickly solve for w. So how do we factor these kind of quadratics? Well, a great way to start this is to realize, oh, we have w squared. So when we factor it, that's going to have w's in the start. And next, the basic strategy, unless we have to use our quadratic formula, is to look at this term right here. We look at this term and we say, what numbers multiply to this term, to negative 40, and add to this number right here? So let me say it again. We're trying to find numbers that multiply to this term and add to 3. So what multiplies to negative 40? Well, I noticed that, and you can list these out, but I noticed that our candidates are 8 times negative 5, right? That's a good candidate because what happens is 8 times negative 5, what's that? Well, that's negative 40. And if we add these two, what's 8 plus negative 5? Well, that's 3, right? So that works. So these are the two numbers. If you find these two numbers that add to this term, multiply to this term and add to this term, you've got the answer. So here I can write in any order. W plus the first term, 8, and w plus negative 5, or just w minus 5. Now these, if we try it, this will multiply back to the original statement. And we could try it really quick, right? W times w, that's w squared. W times negative 5 is negative 5w, but then 8w here. If we add those two up, we get 3w, and 8 times negative 5 is negative 40. So this is still the same thing, it's just factored. Now the nice thing is that if we multiply these two, we get 0. So when you multiply two numbers and get 0, either, well, think about what has to happen, right? If we multiply two numbers and get 0, one of the numbers is 0. So for example, let's say it was 3 times 0, that would get us 0. But it could be the other way around. Maybe the first number was 0, and the second number is another number. You still get 0. And the third possibility is that they're both 0. So here, right, let's assume they're both 0 and see what happens. So first, w plus 8, let's assume that equals 0. If we solve for w equals negative 8, right? We subtract 8 from both sides. So here we're not going to use this one because we can't have a length that's negative. But here on the other term, we have w minus 5 is also equal to 0. If we solve there, we add 5 to both sides, w equals 5. And that works, right? So our width is 5, but we don't want the width, we want the length. The length is 3 more than that, and the length is choice 2, or 8. So you can test this out, width by length. What happens when we multiply them? We should get 40. Well, the width is 5, the length is 3 more than that, or 8, and that works. 5 times 8 is 40, so we found it. Now you could have just went through the choices here to figure this out, but if you're not given the choices, you might need this kind of technique where you factor it and then you simplify it, combine like terms, simplify, and set it equal to 0, and then find the roots, the factors, and then find the value of the variable and plug it back in. So this might seem a little complex, but it's definitely going to be helpful in all problems like this. Thanks.